Hi, we are United Renewable Energy. Today we will talk about how we play a role in net zero. As we know, climate change and global warming is not a science prediction now. It already became a real topic we have to face every day. So world-leading company already set transform to net zero as their long-term challenge. My name is James, a R&D Manager from United Renewable Energy. We call it URE. URE is the single largest vertical integrated green energy company in Taiwan, which founded from 2005 with 500 million capital. We also provide over 2,000 job opportunity to people all around the world. As we said that we are vertical integrated green energy company. Our core product is solar cells and solar modules. And we also provide PV system, energy storage system, and the new energy, like hydrogen vehicle. Our production line is based on Taiwan, China, and Southeast Asia. Our total capacity is roughly 3.6 gigawatt per year. And our products are sold to Europe and basically all around the world. So back to the topic, how we play a role in net zero. As we said that net zero already become a touchable challenge, and the world-leading company already set 2050 target to reduce the greenhouse gas emission to the level of 2005. So the target is already there, but how we achieve it? Transportation, lifestyle, process flow, and green energy are key factors to net zero. And here we URE play a role which is green energy. So as a green energy company, what URE can do to achieve net zero? Here we have two directions. First is to provide a new type of module, which is easy recycle module. The second one is to provide higher efficiency solar module and to make the process flow more efficient. The first thing we can do is to provide easy recycle module. Before we introduce easy recycle module, we will introduce what kind of material we use in PV industry. And then we will talk about how can we achieve easy recycle module and make the module recycle easier. The mainstream encapsulant in PV industry is EVA. Trace back to the history, why EVA became a dominant encapsulant material in PV industry. It is from an earlier project from JPL, which is called Low Cost Solar Array Project, LSA project, from 1978, which set up a cost target 50 cents in 1986. 5 years later, NASA finished the study. And according to their study, it said that EVA is one way to achieve LSA target. So that's the reason EVA jumped up to our face. And we start to use EVA till now. So everything is very good now. And finally, we achieve the cost target since 2015. But here comes a new topic, recycle. PV module now is hard to disassemble and hard to recycle. With the new topic coming, we have chance to co-work with each to have a new type of material to that PV module easy to recycle. What our partner do is to add on a new TPE layer on EVA. With the new TPE layer, PV module can easy to be disassembled with low temperature heating. And it won't bring negative impact to PV module process and also PV module performance. And that is how we can achieve easy recycle module. One more important thing is this kind of material is 100% local produced. It can reduce 95% greenhouse gas emission from material shipping. In the beginning, we need to take over 2,000 kilometers from raw material to production line. And now, we only take 60 kilometers from raw material to PV production line. And it can reduce 95% greenhouse gas emission due to local production. So that is our first direction we can do, is to provide an easy recycle module with local produced material and help to achieve net zero target. And the second thing we can do is to provide a high efficiency module. What we do is to choose heterojunction cell technology. We call it HAT module. There are many advantages from heterojunction cell technology. Heterojunction cell can have higher cell efficiency. It can achieve 24.6% to compare with conventional PPERC module and PPERC cell. The PPERC cell efficiency is roughly 22.6% to 23%. So it can have 2% higher than conventional cell technology. And it also brings higher module power. The second thing is heterojunction module can bring more energy yield. It did not only have higher module power, it can bring more energy yield from lower cell temperature coefficient and also bifacial power generating. Beyond performance-wise, heterojunction module and heterojunction cell is also have lower energy consumption in process. Heterojunction cell only have 6-step shorter process flow. It reduced 50% process to compare with conventional PPERC module, PPERC cell. And the cell process temperature is also lower. It reduced from 800 degrees to 200 degrees. In order to prove the better field performance, we URE built up 2 PV systems side by side on our rooftop. One is heterojunction module system. The other one is conventional PPERC module. According to our study, heterojunction module can get 19% more energy yield due to low temperature coefficient and the bifacial power generating. And with the temperature increasing, heterojunction module also bring more energy yield to compare with conventional PPERC module. And the 19% more energy yield can roughly separate it into 6% from low temperature coefficient and 13% from bifacial power generating. So that is the evidence heterojunction module can bring more energy yield to compare with conventional PPERC module. So the second thing we can do is to provide high efficiency, more energy yield, shorter process flow, and lower energy consumption process heterojunction module. That is what we can do to net zero and that is our second direction. So back to the topic we talked about, net zero. What can we do to net zero? The first one is to provide an easy recycle module with local produced material. The second one is to provide a high efficiency heat treatment module. That is how we play a role in net zero. Thank you for your attention. And we are United Renewable Energy. I'm James. Thank you very much.